So, hello everyone. Now we're going to see the question middle of the linked list, that is 2 from your linked list concepts. So, let's just start with the middle of the linked list question. Let's just begin. I'm just creating up a linked list that has 5 nodes. Okay. And we will go with your approach 1 first. So, what does your approach 1 says? And this is what has to be returned as the answer because this is your middle of the linked list. So, I have to return 3. Not return 3, but return the node with the value 3, right? So what does your approach 1 says? Your approach 1 is very simple. It just tells you one thing that, okay, I trade through the linked list, traverse through the linked list and find n, that is your number of nodes. So you get to know, okay, it's 5. And then what do? You find 5 by 2. That says what? So then you find the mid. How do you find the mid? Now what it says that, okay, if you have been given 4 elements, okay, in that case, you have to return the second node, the second mid node. 2 and 3 are middle in here, so you have to return the second node. Makes sense? Now here it is 4, right? The node size would come here as 4. But I want to take it until what? I want to take it until the count of 3. So that is your 5 by 2 plus 1 is what counts your mid node. So until then, you have to go and then you have to return the node that you are currently on. Like to say this becomes 3. And then I have to go until 3. This was count 1, count 2, count 3. And wherever I am, I have to return this node, right? So this gives me a time complexity of O of n at first for the first traversal and then O of n by 2. Make sense? Right. That takes approximately O of n, big O of n. And the space complexity, we aren't using any extra data structure. So this is O of 1. Now let's come to do this in a better way. Because if you're going into an interview and the interviewer asks you such a simple question, he is not expecting a simple approach to that simple problem. Yes, you have to tell this approach without any doubts because you cannot jump to the optimal approach at the first, right? So you have to start with this approach and then take him to the another approach because this is basically O of n and O of n by 2. Now let's just come to another one. So again, I'm going to draw up a linked list with 5 nodes. So we're going to use tortoise and hare algorithm. And this algorithm we're going to use so much in linked list, right? So this is your slow pointer and this is your fast pointer. So see, fast pointer is moving at a speed that is twice of the slow pointer. So can we safely assume that when a fast pointer reaches the end of the linked list, the slow pointer will be at the mid? Makes sense? Because fast pointer is moving at a speed that is 2x of my slow pointer. So the distance covered by the fast pointer at some instant would obviously be twice of the distance that is covered by the slow pointer. So if the fast pointer has reached the end of the linked list, my slow pointer would be pointing to the mid of the linked list. Makes sense? Makes sense. So now, if my fast pointer is here, it jumps next. In next, it jumps here. And the slow pointer moves here. In the next iteration, fast pointer moves here. And my slow pointer moves here. Now, fast pointer has already reached the end of the linked list. So where is my slow pointer? My slow pointer is onto this node and this node I have to return. Makes sense? Let's just see it now for the even number of nodes. So let's just say I have 1, 2, 2 points to 3, 3 is next pointing to 4s and 4 next pointing to null. I have my slow pointer here. I have my fast pointer here. In the first iteration, my fast pointer jumps to 3. while my slow pointer moves to 2. In the next iteration, my fast pointer moves to null and my slow pointer moves to 3. So what is it? I have to return the second node of the middle node. So this is correct. I have to return slow. So do you see in both the cases, we have to assume safely that either fast is going to, either fast next is going to be either fast. So while loop is going to run until my fast is not equal to null, or fast's next should also not be equal to null. Are you getting this? Is it making sense for you? How am I doing this? All the things, why am I using it? How am I doing it? Right? Because in even, your fast is going to be at null. While when we're talking about odd, because if it jumps from here, right? From null to null, there is nothing here. So your code is going to throw you an error if you're going to do this part here. Does that make sense? Okay. So now we are going to just code up this part telling about while, so I've started up with the while loop. We're just going to do this. One more important thing that you have to keep in your mind whenever you're doing, whenever you're doing or dealing with your tortoise and hare algorithm is that please don't, if you write it like this. Okay, if you write this like this is going to be, your code is not going to run and you're going to get an error. Now, why are you going to get this error? Let me discuss this. When fast is equal to null, that means fast's next does not exist, but your code is going to go by this. Your code is going to, point to fast next or is going to reach to fast's next, which does not exist, and hence it is going to throw an error. So you have to make first this check. If fast is not equal to null. Are you getting it? Because you cannot reach to or you cannot point to fast's next when fast is null. Okay. So first we have to check on this conditional. So let me just quickly go to your coding part. You have to return a node, middle of the linked list. You have been given your head of the linked list. You have to create your slow pointer. Your slow pointer points to head. You have been given your fast pointer. Your fast pointer points to head. And then while fast is not equal to null, right? And did I put or there? No. And if either of them happens, we are done, right? Fast's next is not equal to null. Make sense? So what we have to do? Slow moves to slow's next, while fast is going to jump to fast's next. After we've done with this, we're going to return slow. Does that make sense? Right? So in this way, if you see, we have approximately iterated over the linked list, traversed over the linked list. Because we're missing one node, then moving to the next node. Missing one node, so if the length of the linked list is n, my fast pointer moves, my fast pointer points to how many nodes? N by 2 nodes. 1, 3, 3, 5, 5, 7. And at the same time, my slow pointer moves to n by 2. Because slow pointer is not going to exceed your n by 2. Because slow pointer never goes to the other side of the linked list. It points to its end, that is the mid of the linked list. Right? This is your time complexity. And then when you come to your space complexity, it's just O of 1. I hope everyone is good with this. If you have any doubts, please post in the comment section. You can also make use of the GForms link attached. You can post there any question you want me to take up. It could belong to linked list or it could belong to any other data structure. If you have any subject that you want me to take up, you can post that as well. Right now, I'm making up a playlist on blockchain. So if it's a concept of 2 to 3 videos, I'll take it over the weekend. But if it's a subject, I'll take it post blockchain. With this, I think I'm good to take leave. If you were able to extract 10-20% out of the video, and if you found the video helpful for you, just go in, like the video, and subscribe. Thank you so much. Bye bye.